Hi, everyone. My name is Phil Bates, and I'm a Senior Analytics Specialist Solution Architect with AWS. Welcome to our session, Get Started with Analytics in Seconds with Amazon Redshift Serverless. First of all, why Amazon Redshift for your data needs? With Amazon Redshift, you can analyze all of your data and get performance at any scale with low and predictable cost. Based on our customers' feedback, we have doubled down in three major areas. We've been laser focused on performance at any scale since the beginning and continue to be so. Performance intensive, complex analytic workloads have become the norm in almost every industry, and getting to real time insights is critical today. You've got all kinds of data coming in from everywhere, and this is where Redshift's position within the modern data strategy and the AWS analytics ecosystem is crucial to help you analyze all of your data. This could be your log files, your transactional data, your clickstream data, semi-structured data, or even nested data. And finally, Redshift's goal is to provide an easy analytics solution for everyone, where you can get insights in seconds and focus on delivering on your business outcomes. Today, Amazon Redshift offers customers full control over data warehouse clusters so that you can optimize cost and performance based on your workload requirements. You have the ability to select instance type and the size of your cluster. You can choose between manual and automated workload management. You can resize your cluster and use concurrency scaling to adapt to changes in workload or the number of concurrent users. Redshift Serverless builds on all these great features and capabilities. So while managing data warehouse clusters is a core competency of database administrators, customers want to expand analytics usage to data analysts, developers, and data scientists who may lack this experience. Furthermore, the data warehouse needs to optimally run analytics workloads in the face of changing requirements. This could be the number of users or the complexity of the queries, or perhaps the volume of the data being processed. For example, you may have a dashboarding application that is queried by thousands of data analysts. They can have changing demands throughout the day based on traffic patterns. Or maybe you want to quickly set up an environment to experiment with new data and analytics so that you can get a product to market faster. Customers need and want the ability to respond to changing requirements without having to think about managing data warehouse clusters. And they want a solution that retains all the enterprise data warehouse capabilities. And especially important, you don't want to trade off the performance for the most complex workloads or have to pay more for automated provisioning and scaling. They want to be empowered to use the data easily and get value from it without compromises. Now, let's talk more about Amazon Redshift Serverless. The first tenet of Redshift Serverless is the simplified user experience, so that you don't need to think about selecting the right node types or the node count. You get started in seconds, and you land right in Query Editor V2, and you can start running queries. Redshift Serverless intelligently and automatically provisions and scales your data warehouse capacity to deliver consistent and fast performance. With Redshift Serverless, you still get all the rich SQL capabilities and performance characteristics of Redshift, including querying into S3 Data Lake or operational databases, and also using data sharing to share data with other organizations. Our AWS services integration has enabled customers to continuously use Redshift as their primary data store, but combine data with other data stores without leaving your data warehouse. This reduces the need to build additional ETL pipelines that could take days or even weeks. And with native integrations like Redshift ML, you use SQL to create and make predictions with machine learning. The best part, if you are not using the warehouse, you pay nothing. You pay only for what you use. Now let's take a little bit of a deeper dive into Redshift Serverless and introduce you to all of the key capabilities. The second tenet is intelligent and dynamic compute management. Redshift Serverless automatically provisions and manages the compute resources by making right sizing decisions to match the changing workload demands of your business. We built this by leveraging a lot of innovations that we've been building in the past several years underneath and adding even more. Core to these innovations include the separation of storage and compute, which has allowed our customers to automatically scale data warehouse storage capacity without having to pay for additional compute resources. Redshift Managed Storage and Amazon S3 are at the core of this. Also, auto-scaling clusters or concurrency scaling provides the ability to manage variable workloads. Additionally, we introduced Aqua or Advanced Query Accelerator, which is a hardware accelerated cache that boosts queries up to 10x faster than other cloud data warehouses. Also, the Spectrum Fleet to optimize data lake queries, data sharing, materialized views, auto refresh, and auto query write, plus many more, are at the foundation of this capability. Now, a deep understanding of the workload patterns is really what's critical to make this happen. And this is built by continuously monitoring the queries and applying a variety of advanced machine learning techniques. We use this understanding to implement the automatic management features. For example, automatic workload management, or WLM, which is determining whether a query is small, medium, or big, and appropriately allocating resources for it. We use this to determine when to scale the compute resources and what to scale to so that we can maintain consistent performance but also optimize cost. Redshift Serverless also automatically applies table optimizations by adjusting data object properties and data layout based on query patterns. This further improves performance, eliminating the need for experts to manually tune clusters. Redshift Serverless shuts down the compute when there is no activity and resumes the compute resources when queries start arriving, enabling you to just pay for what you use. With Redshift Serverless, you pay for compute and storage separately. Compute capacity is measured in Redshift processing units or RPUs, and you pay for the capacity for the workload duration on a per second basis. Serverless automates the capacity management by making the right sizing decisions and scales the capacity elastically and automatically based on your workloads. One RPU has 16 gigabyte of memory with corresponding CPU and networking. Data lake queries are part of the same RPU hours. This is moving away from the per terabyte based pricing of Spectrum. For data, you pay for data stored in Redshift Managed Storage at the existing fixed gigabyte rate per month. There are some other data related charges such as snapshot storage and data transfer cost. With serverless, customers can restore their data warehouse to specific points in the last 24 hours at a 30-minute granularity. This is also free of charge. Here is an example to demonstrate of a simple pay for use. So in this example, we're looking at usage of a serverless endpoint over 5 quarters. As a very simple example, we're looking at Q1, Q2, and Q3, and Q4, 5, where we're looking at how long the endpoint has been in use. So you can see here we averaged about a total of 3 minutes query execution time for Q1, Q2, and Q3, a little over a minute and a little over 5 minutes in Q5. So that's a total of 5 minutes and 30 seconds in our simplified example here. But the key point that I want to make here is when you see that idle time, you're not paying for that. You're only paying for this workload duration which is metered on a per second basis. By default, Redshift Serverless automates the capacity management. But if you would like some control on the performance and cost, you can optionally use base and max settings. Base allows you to specify the base data warehouse capacity that Amazon Redshift uses to serve queries. Base capacity is specified in the Redshift processing units or RPUs. Setting a higher base compute capacity can improve the query performance, especially for data processing and ETL jobs that may process large amounts of data and perform transformations and enrichments. Out of the box, base is set as auto, allowing Amazon Redshift to assign and adjust the right base data warehouse capacity automatically without any user intervention. You can adjust the base from 32 RPUs up to 512 RPUs in units of 8 increments. You can do this from the Amazon Redshift Management Console or by invoking an Amazon Redshift API. If you choose the max setting, this also allows you to specify usage limits and defines actions that Amazon Redshift automatically takes if those limits are reached to maintain your budget with predictability. Max is specified in RPU hours and associated with the daily, weekly, or monthly duration. Setting a higher max compute capacity can improve the overall throughput of the system. This can be especially beneficial for workloads that need to handle high concurrency while maintaining consistently high performance. You can also adjust the max setting from the Amazon Redshift Management Console or by invoking an Amazon Redshift API. And also, best of all, no changes are necessary for existing analytics and business intelligence applications if you are going to migrate from a provisioned Redshift cluster to a serverless endpoint. You can continue to leverage all the rich analytics functionality of Amazon Redshift, such as complex joins, direct queries to data in the Amazon S3 data lake, and operational databases, materialized views, store procedures, semi-structured data support, and machine learning, as well as high performance at scale. All the related services that Amazon Redshift integrates with, such as Amazon Kinesis, AWS Lambda, Amazon QuickSight, Amazon SageMaker, Amazon EMR, AWS Lake Formation, and AWS Glue, continue to work with no changes. For data migration, you can take a snapshot of an existing Amazon Redshift provision cluster and restore into a serverless endpoint. For SQL applications, you need to change them to point to the new JDBC ODBC endpoint, and then everything will work seamlessly. Any management scripts that you may have built on a Redshift provision cluster SDK need to be modified as Amazon Redshift now provides a new SDK to manage the data warehouse. Also, you can use data sharing in Amazon Redshift Serverless just as you've been able to do for quite some time now in Amazon Provision. You can share data from an Amazon Redshift Provision cluster to a serverless endpoint and vice versa within the same or in different accounts or in different regions. You can also share data across Amazon Redshift serverless endpoints in different AWS accounts or in different regions. Data sharing enables several use cases, and most importantly, it eliminates the need for data movement. You can size and scale individual workloads according to their performance requirements. You can provide workload isolation while sharing common data sets. Seamlessly collaborate across business groups for broader analytic capabilities. And this also gives you the ability to do fine-grained chargebacks. Now let's take a look at some Amazon Redshift serverless use cases. Number one goal with serverless is to provide easy analytics. And this is especially important when you're addressing variable and sporadic workloads. It allows you to scale resources seamlessly as those workload demands change or spike with traffic. Amazon Redshift Serverless uses machine learning techniques to maintain this consistent performance. Serverless is also great for development and test environments where you need to spin up a development environment quickly easily and economically, and do experimentation, bring in new data sources, etc. It's also great for impromptu business analytics when you want to do some what if scenarios, anomaly detection, or ML-based forecasting while getting fast insights from your data. Now let's look at some of the workload types we see that are also good fits for serverless. First case is taking a look at variable workloads. And what we mean by variable in this case is you may have sometimes where you have high query concurrency, or maybe sometimes you have a lot of data scanning going on where you're doing aggregations, etc. This is a great use case. You can scale up and down according to this variability and only pay for what you use. In this use case, you may have a more known workload where you know there are periods where there's no activity at all. You now no longer need to worry about pausing and then resuming resources. Redshift Serverless will automatically take care of this for you. Again, as we saw, no need to pay for that idleness, and it's much easier to manage now. And finally, another good use case is when you have a steady state where you have a predictable workload. For the most part, clusters doesn't have long periods of idleness, but you do have spikes. Again, this is a great use case for serverless where you can seamlessly and automatically scale up and down to meet these spikes and get that consistent performance that your users demand. Now I'm going to walk you through a demo to show you Amazon Redshift Serverless in action. You will see how easy it is to get started with serverless. You'll be able to load data and run analytic queries in a matter of minutes. I'll show you how to use Query Editor v2 to create copy commands in a no-code fashion. Also, we'll show you how to create a schema to query the data lake with a simple point and click. We'll also demonstrate how you can create multiple endpoints and how to monitor the usage of your serverless endpoints. Getting started with Amazon Redshift is easy. You can simply click on Amazon Redshift and then click on Try Amazon Redshift Serverless. You will see two options in configuration. One is to use the default settings or the custom settings. For our demo here, we're going to use the default settings. Choose Save Configuration, and this will take just a couple of minutes, and then our Amazon Redshift Serverless endpoint will be ready. Now that our endpoint is ready, we can go to the Serverless Dashboard. You'll notice a couple of things here. You'll see namespaces and work groups. A work group is what manages the compute plus the networking and security. This is also where you connect with your tools via JDBC, ODBC, or Data API. The namespace manages the data. Let's click on our work group and see what it looks like. And when you go in there, the first thing you'll notice, you'll see our work group name. You'll see the endpoint. Again, that's what we'll use to connect. You'll see your networking and security settings. Also, this is where you can manage your limits that we talked about earlier. So you can set and manage limits for the base capacity of RPUs. So let's click on this and see what our options are. You see it's set to our default of 128. And if we wanted to change that either up or down, this is where we would do that. You can also manage usage limits. This is where you can make sure that you don't go over any overruns, you stay within your budget. So we don't have any, but if we wanted to, we could add these. You could add these at the daily, the weekly, or the monthly level. So for example, you could say, if I go over 15 RPUs in a day, I'm going to take an action to log that to a system table so I can be alerted of it and monitor that. Another type of limit you can do is a query limit. Let's say that you want to have limits and controls in place to protect the system for potentially runaway queries. So if you could do a query execution timeout. Let's say, for example, if a query ran longer than 50,000 seconds, then you could have that query canceled. Let's go back to our dashboard again and take a look at our namespace. Again, the namespace is where you see information about your data and your storage. You can see how much storage is used so far. You can see things like total table count. We haven't created any tables yet, but we will in just a little bit. So what we can do is we can go into Query Editor V2, and I'll show you how easy it is to get data loaded now and actually start running some real analytic queries. So you'll see here we have our serverless endpoint that we created. We also have a Redshift provision cluster that we previously created. So there are two databases that got provisioned there. There's a dev database and a sample database. As you see, we don't have anything in our dev database yet. And I'll show you a little trick here on how easy it is to load sample data into your serverless endpoint and start running these analytic queries right away. So you'll see a ticket, a TPCH, and a TPCDS schema. So let's click on the TPCDS schema, and it's going to open some sample queries. And it says we don't have a sample database yet, so simply say create. And in just a couple of minutes after you do that, you're going to have a set of data that is great for running analytic tests and analytic queries. So you can see that our sample data dev has been created successfully. We now have 25 tables in our TPCDS data set. It also automatically creates sets of queries. There are essentially 100 queries standard that you can run with TPCDS for analytic and testing. And it actually splits these up into sets of 10. So like 1 through 10 and 11 through 20 and so forth. So let's just pick a set of 10 and run it so that we can check out how these queries run in our serverless endpoints. It's also going to be something that we can check out when we monitor lately and see our usage. So we're going to run these queries now. And you can see we're already running analytic queries. We're analyzing things like getting sales information, gross margin, checking out typical kinds of things that you would do for a retail environment. Okay, we see our queries are coming back. We see some of our results already. And we ran 2 different queries, so we have 2 different result sets here. So now that we've done that, we can also, in addition to doing this, we can also load data via a copy command and without writing any code. So this is also something you can do here from the Query Editor V2. And the way that you do that is up there in the upper left-hand corner, you click on the Load Data button up there. And you're going to browse S3 and find the bucket. Now, what I did for this, I actually got some New York City taxi data from the publicly available site, and I've got 2013 October. I also pulled down October or September, I believe it is. This is October, so we're going to select the October data here. Say choose, and then you'll choose an IAM role. There's that one that's associated with our endpoint. This particular file, I know that it does have a header record. So if you go to advanced settings in say data conversion parameters, there's an option in there where you can ignore the header row. So we'll go ahead and select that and just say done. And then we need to tell it where to load it. So down the target table, we're going to select a schema, and we'll use the public schema in this case. And we've got a table in there for this, the New York City taxi data set. And you simply say load data. And not only does it generate the copy command without you writing any code, it actually executes it as soon as you hit load data. So all this was able to be done with just point and click and not writing any code. And we can do a select from our table just to validate that data is actually there. And we see, voila, we have our data. So now, in addition to doing this, you can also easily, if you want to query data in your S3 data lake, you can also create an external schema from within here, from within Redshift Query Editor v2. You click on the Create button and Schema, and then you'll give the schema a name. In this case, it's an external schema. And we will, we're going to use our Glue catalog in this case, so we'll choose that Glue database. And then you simply say create schema. And you see there under our sample data dev, we now have that external schema Redshift demo has been defined. We have the one table there. In this case, I also use the New York City taxi data again for the external schema demo. This is the one where I'm using a different month. I'm using September. So we can do a quick query on that to validate that we can actually see that schema in S3. I just need to type the correct schema name here. There you go. We are now querying data from our serverless endpoint against our S3 data lake. So you can easily do that, which is a point and click. Now let's go back to our dashboard, serverless dashboard here. Now, you may have a need where you want to create another serverless endpoint, maybe for another application or another team. The way you do that is go in by creating a new work group. First thing you do is give the work group a name. For this demo, I'll just call it work group 2. So that's different. We use default on the first one because I didn't change the default name. Now you can also, default is 128 RPUs on the capacity. So for this demo, let's just make it something different. Let's make it 168. And you can also, now for a namespace, we're going to create a new namespace. You can add it to an existing namespace, but our existing namespace is already being it's already connected to our first work group. So in that case, we're going to create a new namespace. So just give that a new name as well. You can also customize any admin user credentials here as well if you need to. And we're going to associate the IAM role and make it default. And then we'll say next. And then we'll simply review and be able to create this endpoint. So now you can see our new endpoint. You see the namespace 2 and workgroup 2 are in the process of being created. Now they are completed, and we can take a look at this. Let's go take a look at our work group that we just created, and we get some information such as our endpoint. Again, that endpoint is where we connect from any tools that we have, our applications that need to get to this serverless endpoint. Let's connect to our new endpoint. We'll just use federated user. So create the connection. So we can do the same thing here that we did before. So again, let's create the TP-CDS data and queries. That way, we can run some more queries or a different set of queries against our new serverless endpoint, and then be able to do some monitoring and compare those to what we already ran to our default or our first serverless endpoint that we were looking at earlier. So again, we have those 10 sets of data queries that are created. Before we use, I think, 21 through 30. So let's choose a different set of queries this time to run so that we can just compare that with our first run that we did. So we'll try 61 through 70. And we will run those queries. Again, hopefully you're able to see how quickly it is to get data loaded and start running analytic queries here. We can take a quick look at some of our results here. Again, seeing things like sales information, price information, item information, that kind of thing, right? So good, typical kinds of queries you may see depending on what kind of business. Now, let's go take a look at some of the monitoring things that we can do now. So it's very easy to monitor. You just go back to the console here. You can do it at resource monitoring level. You can do query database monitoring. So, for example, we can take a look at our first work group, which is our default work group. You can see things like query history here, and you see database performance. You can also easily see the recent queries and loads that have ran. You could drill into those, see things like explain plans or anything like that you needed to see as well. And this is one way that you can see. You go to resource metrics. This gives you one way to take a look at the RPU capacity that you have used. So this is really a nice way if you need to track. You want to make sure that you're staying within your range and see what kind of peaks and valleys you may have. But you see here that kind of coincides to when we ran the first set of TP-CDS queries on our default or on our original serverless endpoint. See, it peaked at about 128, it looks like. You see database connections and things like that. So let's take a look at the other work group that we established, work group 2. And you can see it looks a little bit different. We just now submitted those queries. We just had that brief spike, and it got up to about 134 RPUs, and then it came back down. You can see looks like we almost got to our full capacity, but not quite. And again, things like database connections and things like that you can see. You can also go to the resource monitoring tab and get another view of our RPU capacity used as well. So again, this is looking at that default work group. This is a quick way to see RPU capacity, along with if you wanted to go down and see the RPU seconds as well. This is a great way for you to check and see the usage, what kind of trends you have, where the peaks and valleys are, and be able to get an idea of billing patterns based on the RPU seconds. Again, we can see workgroup 2. We just recently ran those. We just had that one spike there because we didn't run as many queries. There wasn't as much activity there. So again, I hope that you have enjoyed this demo. I hope it's been useful and you've been able to see how easy it is to get started with Redshift Serverless, to be able to quickly run analytic queries, be able to run copies with no code, query your S3 data lake, and be able to do your monitoring all in one easy to use interface here. Thank you very much for your time, and we are now available for Q&A.